Hey everyone, hope everybody are doing good and welcome back to Homeschool. And I have come up with a beautiful video series for class 12 students, and here I am coming up with the major concepts of class 12 syllabus, that is chemistry syllabus. See, you actually have the 50 major concepts, okay, on which questions can be frequently asked from these particular topics. From all the 16 chapters, I have carefully selected the 50 concepts. Okay, so here I have come up with the 50 concept videos along with solving question paper questions, previous year question paper questions. Okay, so I am going to deal with the JEE and NEET previous year question paper questions from these major 50 topics of class 12 syllabus. Okay, so as a part of helping the students who are going to write their NEET, JEE, CET and various entrance examinations in the year 2024, these videos are the most beneficial for you. Trust me, they are going to be the wonderful videos. Why? Because along with the concept, then and there I will show you how the questions can be asked and how easily you can solve the questions. And I always tell you guys that chemistry is like a trump card, right, to clear your NEET and JEE examination easily, because physics, some level of difficulty is always there however you prepare. Bio is a kind of easy category and chemistry is a mediocre. So chemistry is like your trump card to increase your score in NEET and JEE, CET examinations. So if you can concentrate these 50 topics of class 12, initially I'm starting with class 12, later I will deal with the concepts of class 11. Okay, so these 50 concepts I'll explain you quickly in a quickest way possible along with the questions relating to that. Not only that, when it comes to calculation part, I will also show you easy ways of calculations. So I'll come up with lot of tricks and tips to calculate easily and to find the answers easily. Okay, so initially I am actually starting with a solutions chapter because this is the most fundamental and easiest chapter. So let me start our sessions with this chapter called solutions. So in a solutions, you have three major topics on which you have to concentrate. So topic by topic, I am making a video. So almost 50 concepts, right? On 50 concepts, I'll be doing around 50 videos, 50 to 55 videos, okay, on each and every concept. So here in the first video, I am coming up with the topic concentration terms. This topic is actually pretty simple and easily you can get a mark in case if the question is asked from this particular topic. Okay, first let me revise the concept, like how much you should know, how much extra you shouldn't worry about, and all that I am going to tell you. Okay, so the major problem with students is they study more than needed actually. Okay, but nowadays, I mean from past 4 to 5 years onwards, especially in the NEET examinations, they are not going out of NCERT. Everything, especially when chemistry is concerned, everything they are asking from NCERT book itself. You know what? Majority of the questions they are framing just like backside questions, like exercise and in-text questions type only. Okay, so if you can thoroughly read NCERT textbook line by line and if you can thoroughly practice in-text exercise questions, that is more than enough, guys. And if you want a detailed explanation of all these chapters and if you want to have the solutions of all in-text and majority of the exercise questions, So we have a beautiful course in homeschool application, that is class 12 physical chemistry course and organic chemistry course. Both are available. If you are interested, if you want to learn it in a best, easiest, best detailed way, then that's the best course, and download homeschool application for that. Link is provided in the description. So now I'll quickly go back to the topic, concentration terms. So here you majorly have to concentrate on these concentration terms. One is mass percent. You can also represent this by W percent. The other one is mass by volume percentage. Okay, other one is volume by volume percentage. Mole fraction, right? Molality, and ppm, that is parts per million. So these are the concentration terms you have to focus here. And now let me give you the formula that you have to remember in every concentration term. See, some of you would remember almost around 20 to 25 formulas regarding this concept, but remembering those formulas is like so much burden for your brain, because you have to remember so many things, and upon that all these things like a huge burden. So here I am going to solve the questions with the basic formula of these concepts. You no need to remember extra formulas, nothing is necessary. Okay, so only the basic versions, their definitions, if you can understand, that is more than enough to solve any question that comes from this particular topic. Okay, so first let me explain them in a brief way. Coming to mass percent, that is W by W. Okay, it is nothing but mass of a component, mass of any component, it can be a solute or solvent, okay, present in 100 grams of solution is called mass percent, guys. Suppose if you want to calculate mass percent of any component, suppose mass percent of a component A I have to find out. So what is the formula? Mass of A divided by total mass of solution. Okay, so in the denominator you have to take total mass of solution multiplied by 100. Okay, so here usage of formulas is very little, guys. Question may not be asked specifically on just the mass percent or mass by volume percent or volume by volume percent. Here what is important is their meaning. Suppose in a question they have given some component A which has got 5% W by W. Okay, so this is how they'll mention the information in a question to solve something else. Okay, so you should carefully understand what is this 5% W by W. It means 5 grams of this component A is present in 100 grams of solution. So this meaning is very, very important to understand. Okay, see here how much amount of solute, that is A is there, 5 grams. How much amount of solution, that is mass of solution, is how much? 100 grams. If I ask you what is the mass of solvent, what is the mass of solvent here? So what do? Solution, mass of solution, that is 100 grams minus 5 grams. If you do, you will get 95 grams. So this is mass of solvent, guys. Okay, so this way of understanding is very, very important. Similarly, you know what, volume by volume percentage. Okay, if you have to calculate volume percentage of any component, then it is, okay, you have to consider volume of A divided by total volume of solution multiplied by 100. Okay, so the same formula. Initially you took mass everywhere, now you are taking volume everywhere. Okay, say suppose I have 5% volume by volume, right? If the information is something like this, it means 5 ml of a component, let me take A, present in 100 ml of solution. Okay, say here everything solute we are considering in volume, and solvent also we have considered in volume itself, right? And most important is mass by volume percentage, guys. Mass by volume percentage in the sense solutes. See, if you have to calculate mass by volume percent of any component, then in the numerator you will take mass of component. Suppose if your component is A, you want to find out its mass by volume percent, then in the numerator take mass of component, and in the denominator take volume of solution multiplied by 100. Okay, so that is a formula to calculate mass by volume percent. Suppose if someone in a question you have 5% mass by volume, right? If this is the case, then what exactly it's meaning? It means 5 grams of solute, some component that is solute, present in 100 ml of solution. Okay, so this is very important, right? So solute you considered in mass term, and this much amount is present in this much ml of solution, 100 ml of solution. Okay, so here volume of solution is given and mass of solute is given. Then that is what we mean by mass by volume percent. Okay, so as I already told you, question may not be specifically asked on this aspect, but these terms meaning is important to understand. Now very important, coming to mole fraction. Okay, so suppose you have a component X and Y. Okay, X let me call it as a solute and Y let me call it as a solvent. So in the entire chapter we focus on binary solution. Binary solution in the sense a solution which is made up of two components, right? So one component is called solute, the other component is called solvent. So which component do you call it as a solute? The component which is present in minor quantity. Okay, if it is present in a very little quantity, then that component is solute. The component which is present as a major quantity, okay, large amount of component if you find in a solution, then that component you are calling it as a solvent. Okay, so this is the very fundamental aspect. So now we have component X and Y, solute and solvent. I want to find out mole fraction of X. So mole fraction of X is nothing but moles, number of moles of X divided by total moles. Total moles in a solution. Okay, total moles in solution means what? Moles. Moles of X plus moles of Y. Okay, so it is nothing but ratio of moles of one component to the total moles present in a solution. So that one you can write it as a definition. Similarly, if you want to find out the mole fraction, you know this capital X is the symbol for mole fraction, guys. Okay, so now mole fraction of Y, if I have to find, it's very simple. Number of moles of Y divided by number of moles of Y plus number of moles of X. Okay, so this is all about the mole fraction. And you know what? Sum of the mole fractions of all the components in a solution will always be equal to 1. This is very important. Okay, so mole fraction, sum of the mole fractions present in a solution will always be equal to 1. That means you will never get mole fraction value greater than 1. Remember this point. Okay, and you will never have mole fraction value negative, because on the type of value also question has asked in the previous year. Okay, so let me give you one question that they asked on this mole fraction. Look at the first question, guys. So it was a question that was asked in engineering entrance examination. Select the incorrect statement. You know, in chemistry this is where you have to be very careful, both in chemistry and biology. Select the incorrect one, select the correct one. So you have to carefully think what they are asking. Okay, so here they are asking which is wrong. Wrong statement is your option. Okay, see, look at the first option, right? X can be greater than 0, lesser than 1. Yes, X can be greater than 0, lesser than 1. That is possible. And here, look at here, X can be lesser than 1, lesser than or equal to 1. That is also correct. This is a correct statement. This is a correct statement. X is non-negative. That means X is always positive. Okay, X can never be negative. There, see, when you are calculating mole fraction, definitely some moles would have been there, right? So moles is always like positive number only. So this is also correct statement. And now look at here, X can be lesser than -2 or greater than +2, greater than or equal to +2. No, look at this formula. Sum of the mole fractions is always equal to 1. It cannot be like greater than 1, right? So how can you expect like in between -2 to +2? So definitely this is a wrong statement. So you know what? This is your correct option, right? So it's very simple. If you stick on to a concept, that is more than enough in many of the questions, majority of the questions. Okay. So now let me solve one more problem that they asked in the previous year. You know, this was a question from 2011. In different state boards, this question was asked many times. They asked in 2011, they asked in 2015, and they asked in 2013. Like not the same exam, in different state examinations. Okay, but very, very simple. Mole fraction of solute in 1.00 small m, in the sense molal, right? So 1 molal aqueous solution. So mole fraction of solute they are asking. So mole fraction, just first you put the formula, basic formula. Mole fraction of solute is equal to number of moles of solute. Small n means moles, right? Number of moles of solute, number of moles of solute plus number of moles of solvent. But number of moles are not given in a question, right? So this information is enough to get number of moles. 1 molal means what? 1 molal, the meaning of this sentence, 1 molal in the sense 1 mole of solute present in 1000 grams of solvent, guys. Okay, so this is what the meaning of this sentence. So molality means number of moles of solute present in 1 kg solvent. 1 kg means what? 1000 grams of solvent. So from this sentence I got to know number of moles of solute. I got to know how much? 1 mole, right? So now what I have to find is, I also want number of moles of solvent in the denominator. Number of moles of solute we got to know, that is 1. 1 divided by 1 plus this I don't know. But this information is enough to get that. Look at here. Number of moles of solvent we want. Which is the solvent here? Solvent is water, because in a question they have mentioned it is an aqueous solution, right? So it is water. So what is the formula to calculate number of moles? Mass divided by molar mass, right? So this is the basic formula. Mass is how much? 1000 grams, right? And molar mass is how much? Molar mass of water is 18. So 1000 divided by 18 is 55.5. Always remember this number, guys. So this is the number of moles of water, molarity of water. Okay, molality of water is 55.5. So here 55.5. So 1 divided by 1 plus 55.5 is 56. 56.5, no? So you no need to calculate, like again don't waste your time, you know, by doing this division. Just look at the option. See, here definitely if you remove this 1 divided by 56, that means definitely you will keep 0.0, right? So here some digit will come, right? See here 0.1, so this option you can eliminate. 1.7, this option you can eliminate. So now your correct answer is always like either of this 0.035, 0.017. And looking at this, so this is like you will put 100 divided by 56, that means 0.01 only will come. That means definitely this is the correct answer. See, we did not even calculate completely. That's a time waste during competitive exam. Just you can easily eliminate two options. Among the two, carefully you have to select. Okay, so this is how questions were asked on mole fraction in the previous year question papers. Okay, NEET and JEE question papers. So now mole fraction is done. Let's go for the next concentration terms. Okay, so which are very, very important. What is that? Molality, right? Molality, which can be denoted with small m. Okay, and another concentration term is molarity. Molarity is denoted with capital M. So here you should not get confused. So let's compare and study what is this molality and molarity. Okay, see, molality is nothing but number of moles of solute, okay, present in 1000 grams of solvent. Okay, that means 1 kg solvent, and this is number of moles of solute in 1 liter solution, guys. 1 liter solution. Okay, see, 1 liter solution means what? 1000 ml solution it is. This difference here is very, very important to remember. So now let me give you the basic formula. Is equal to number of moles, right? Number of moles of solute divided by mass of solvent. Mass of solvent. This is the basic formula. Now again I know number of moles in the sense mass of solute. Okay, mass of solute divided by molar mass of solute, okay, into 1 divided by mass of solvent. Mass of solvent. Mass of solvent, most of the time they will give it in grams only. If they are giving it in gram, then in the numerator you will add 1000. Okay. So similarly, molarity is what? Capital M is equal to mass of solute. I am directly writing the major formula. Mass of solute divided by molar mass of solute into 1000 I will write, divided by volume of solution here. Volume of solution, if it is given in ml, then this 1000. But if you are taking it in liter, no need of 1000. Here also same thing. If you are taking it in kg, no 1000 on the numerator. So this is the conversion factor. That's it. Okay. So here the unit of molality is moles per kg, guys. So here the unit is moles per liter. Okay. And whereas this molality is there, no, it is temperature independent. This concept that I am telling you is very, very important. Whereas this molarity is there, no, this is temperature dependent, guys. Why this is temperature dependent? Because of this volume is involved. Okay, so you know what? Volume is directly proportional to temperature. Okay, so as temperature increases, the volume expands. As temperature decreases, the volume, it contracts, isn't it? So, since molarity is inversely proportional to volume, our molarity will be inversely proportional to temperature also. So, as you increase temperature, what will happen to molarity? They will ask. Molarity will always decrease. Okay, because volume also decreases. Okay, and this fellow, what will happen for molality if temperature is increased? Nothing will happen, because everywhere mass is independent of the temperature. Okay, so along with molality, which concentration terms are temperature independent? Mole fraction, mass, m by m percentage. Okay, so these three, okay, mole fraction, mass by mass percentage, and molality, these are temperature independent, whereas mass by volume percentage, volume by volume percentage, and molarity, all the three are temperature dependent. Why they are temperature dependent? Because volume term is involved. Volume is directly proportional to temperature. So based on this concept also, theoretical question they can frame, right? And you know what? This is what the basic formulas you need to remember. No need of remembering the relationship between molarity, molality, density, molality, density, molarity. All that is not necessary only, guys. If you know this basic formula, you can solve any type of question. And one more formula I will give you, that is dilution formula. Okay, so this is one thing important, dilution formula. Okay, so that is, for example, molarity, M1 V1 is equal to M2 V2. Okay, suppose they'll give you a particular solution, 0.1 molar, you have 100 ml, and suppose if I have to make this solution to 0.01. Okay, so I have diluted, I have added the extra amount of water, so that molarity has changed. And what is the volume, they will ask you. Volume is question mark. Suppose if you consider this is M1, this is V1, this will be M2, and V2 they are asking you to calculate. So what is V2? 0.1 into 100 is equal to 0.01 into question mark. That is 0.1 into 100 divided by 0.01. If you do, you will get V2 value, isn't it? So now this is how the questions, if they ask, then this dilution formula will help you to solve the questions easily. And sometimes, see here I have asked you the volume, right? Sometimes they will ask you what is the water, how much amount of water is added. Okay, to make this solution from this fellow, from this particular solution, how much water is added? You calculated total volume of solution. How much water added, in the sense you have to do V2 minus V1. So you'll calculate the final volume, now you will get some value. That value minus this V1 value, if you do, you can get the amount of water that's been added. Okay, so this is also very fundamental type of a question that can be asked on molarity. Okay, so now let's look at few questions that they asked on molarity and molality. Look at these questions, guys. Looks very difficult, but trust me, very easily you can solve it without remembering any other formula. Okay, see, understanding the question is very important. Density of 2 molar aqueous solution of NaOH is 1.28 gram per centimeter cube. Calculate the molality. Molarity they gave. Okay, so 2 molar is molarity they gave. They are asking molality. Okay, and many people remember the relationship between molarity and molality. That also they'll mug up. No need of remembering that formula. Look how simple way we are going to do a problem without even remembering the extra formulas. What they are asking you to calculate, that you remember and put the formula. That's it. Molality they are asking, right? So molality is equal to weight of solute. Solute is NaOH into 1000, right? Divided by molar mass of NaOH. Molar mass of NaOH into mass of solvent. Okay, so mass of solvent. Solvent is water here because aqueous solution. So mass of solvent. This is the formula you have to use. See whether all information given or not. Right. So weight of NaOH. Weight by molar mass is nothing but number of moles, right? So I can also write the formula this way. Number of moles of NaOH, say very basic formula I am using, divided by mass of solvent. Mass of solvent. Okay. So you know what? Number of moles you know directly. That's why I wrote it in this form. 2 molar in the sense what? 2 moles present in 1 liter solution. This is what the meaning, no? 2 molar in the sense 2 moles of NaOH present in 1 liter solution. So NaOH is how many moles? 2 moles. So from this information we got to know number of moles of NaOH. So in the numerator what exactly is the value? 2. That I know. And my problem is to know about this thing which is there in the denominator, that is mass of solvent. So how to find out this thing? I will take the help of this information. Okay, see, look at here. You know what? Density is given. Density is equal to 1.28 grams. Say density of solution they gave. So this is of solution. So first I will find mass of solution. Okay, I want mass of solvent, but using this information I'll find the mass of solution first. So we know the formula, D is equal to M divided by V, mass of solution divided by volume of solution, isn't it? So now mass is equal to density into volume. Density they gave 1.28. Volume of solution is how much? 2 moles in 1 liter, right? So 1 liter means what? It is 1000 ml. So what is your answer? 1280 ml I got. 1280 ml is what? This is mass of solution. Mass of solution. Okay, fine. And now what is mass of solute here? So here let me do it here. Okay, so this too I'll erase. Mass of solute, let me find solute. Okay, so we know number of moles is equal to mass divided by molar mass, right? Okay, number of moles of solute is what? 2. 2 is equal to mass, we don't know, molar mass is 40. So mass is what? 40 into 2 is equal to mass of NaOH, that is solute. Okay, so that is 80 grams is solute. This is mass of solution. This is mass of solute. What I want? Mass of solvent. How do I find that? 1280 mass of solution minus mass of solute. 1280 minus 80. So that is equal to 1200. Right? So this much grams is mass of solvent. So I got to know what I have to substitute in the denominator. Now I'll find number of moles of NaOH is 2 divided by mass of solvent in kg only I will take. Okay, if you are taking it in grams in the numerator 1000 you have to do, right? So now 1.2. Right, so what is your answer going to be? It is nothing but, let me write it as 20 divided by 12, right? So 12 ones are 1.8, that means 1.6 something is the answer. See, I'll go for option D. See how easily we have done. See, we didn't remember the extra formula which is actually a relationship between molarity and molality. There is a formula. People remember n number of formulas. In this case, not necessary. See, logically how we found? See, number of moles of NaOH. This is what the clue, 2 moles in 1 liter. Okay, so using this information we found mass of solution, mass of solute we got to know. From that you got to know mass of solvent. You just substituted in the formula and you got your answer. So first you write the basic formula and see what is there, what is not directly given. What is not directly given, think of how to calculate with the given clue. That's it. This is what you must able to think. This thinking will come when you practice with lot of problems and examples. So that on that you have to work. That's it. Okay, fine. And now let us see one more question which is quite different. Okay, last step is what different, nothing else. See, how many grams of concentrated HNO3 is used to prepare 250 ml of 2.0 molar NaOH? The concentrated acid is 70%. So you actually, your question is this much concentration of this much amount you actually have. In that, how many grams of NaOH is there? Okay, so first using a basic formula, let's find out the mass. How many grams in the sense? So they are talking about mass. See, molarity is equal to weight of what is that? HNO3. Okay, so into 1000 divided by molar mass of HNO3 into volume of solution in ml. Okay, so molarity is given how much? 2 is equal to this we don't know, so question mark into 1000 divided by molar mass of HNO3 is 60 into volume is 1 liter. 1 liter means 1000 ml. So this gets cancelled. So you will have 63 into 2, right? Sorry, here I can't keep 1000. They have given the volume, it's 250 ml, right? So 250. So 1s are 4s are. So 63 into 2 divided by 4. So 1s are 2s are, right? So 2 1s are 2 3s are. So 31.5. So you got 31.5 grams of HNO3 is present in 250 ml of 2 molar HNO3. But you need to find how much amount is there in 70% HNO3. Okay, see, look at here. We know the logic. 70% means what? 70 grams present in 100 grams of solution. 100 grams of solution, right? So now 31.5 grams is present in how many grams of solution they are asking. Okay, so what is your answer? You just have to do 31.5 into 100 divided by 70, guys. So this gets cancelled. 7 1s are, right? And then so here you will have 3, that means 1.4. So almost around 1.4 into 31.5 you have to do. Approximately your answer is 45 grams. Okay, see, most of you will select the answer as 31.5. This also is there in option, this also is there in option, but this is not your answer. Again they mentioned like the concentrated acid is this much percentage. Okay, so when they have given a mass percent, last step you have to do this. Okay, so 70% means 70 grams present in 100 grams of solution. So your actual weight is 31.5. So 31.5 is present in how much? So they are ultimately asking a kind of mass percent. Okay, so this is how the questions were asked in the previous year paper. So no need to panic looking at very difficult problems. You know what, restrict to NCERT textbook, that is more than enough. And now I'll give you one question for homework and post its answer in the comment section. Let me check it out who will answer the first correct answer. Look at the question, guys. Molarity of liquid HCl will be, so they are asking you to calculate molarity, and they didn't give anything. They didn't give you weight of HCl solution, molecular mass of HCl solution, volume of HCl solution. Only clue you have is density. Density here, this is what the clue, guys. So use this clue and calculate the molarity. And you actually have a side formula, the relationship between density and molarity, but don't mug up that formula, not necessary. Go on the logic. Density of the solution is 1.17 grams, that means this much grams per ml it seems. So what is your weight? This is only the weight of HCl. Okay, and find out the volume from this information, and you know what, calculate the molarity. I will not give you the options, you just type the correct number, okay, in the comment section. So see you, that's all about this topic, that is concentration terms. So in the next video, I will come up with the most important topic, the colligative properties. Okay, so the most important topic, guys. Majority of the questions that you observe in the previous question papers from this particular chapter, it was on colligative property. So don't forget, in one shot I'm going to explain all the colligative properties in the easiest way, and we are going to solve the questions relating to it easily. Okay, thank you and see you in the next video. Share and subscribe the channel so that you will get the maximum benefit. All the best.